It is strongly recommended, and will be required in Lab 5 and 6, that the experimenter uses options basic and custom in DG-Lent AD2 Wavegen output. Furthermore, it is required for the lab report that if a circuit input and output are to be demonstrated, it should be presented in a two-window side-by-side format. The following shows how these can be done. Open DG-Lent Waveforms app. Click Wavegen for the signal generator. Then, go to Welcome Plus to add the oscilloscope by clicking Scope. To detach the tab and form a new window. Double-click on the tab of Scope or Wavegen to detach the tab and form a new window. Resize both windows as necessary. Side by side or top-bottom, depending on the case. Most of the time, side by side is recommended since there will be other functions on the scope window that will take up space vertically. On the Wavegen window, select Basic. The slider controls can be opened or closed as needed to save space. This example shows first, controlling amplitude. It is recommended to set minimum and maximum limits for each control so that the output parameter will not accidentally get out of range. Now, this shows controlling the frequency. For the phase, it is relevant only if there are two signals. One signal can always have 0-degree phase, the other one is to be set as desired. This shows square pulse waveform. To make a very short pulse, such as for impulse response measurements, use the duty cycle slider. Other waveforms besides sinusoidal and square will be used in Lab 5. There are other functions on the scope you should explore for both fun and learning. This has been shown in Video Lab 4, Part 1, Step 5. Most important, however, is to learn how to use the fast Fourier transform or FFT function. Just think of it as a frequency meter. Change the Wavegen signal frequency and observe how the FFT peak moves. The FFT graph, also called spectrum, or spectral power density of a square wave, is more complex than that of a sinusoidal wave. Learned FFT in another course. If you have learned FFT in another course, you should have fun playing with this function. You can import a custom waveform, and look at its frequency spectrum. Conversely, with a Fourier spectrum, you can reconstruct the waveform. This is the end. The Lab 4 bonus project will involve modulating different LEDs at different frequency, to demonstrate the concept of frequency division multiplexing. Like the blue and yellow spectral lines, each LED signal will have its own frequency that you can detect with the FFT. Have fun!